Hi everybody, today we're going to talk about conditional probability and independent events. Conditional probability is the probability that the event A will occur given that the event B has already occurred. In our notation, we write the event we're trying to figure out with a vertical line showing the event that's already occurred. To calculate the probability of A given B, we find the probability of A and B both occurring divided by the probability that B occurred. This can also be calculated by finding the number of times that A and B occurred divided by the number of times that B occurred. What I want you to notice is that generally the denominator of our probability is the entire sample space. For conditional probability, the denominator changes to reflect that the event B occurred. Let me give you an example. Let's say I'm thinking of a US president. Can you guess which one? Since currently there have been 45 US presidents, you have a 1 in 45 chance of guessing correctly. Notice the 45 in the denominator represents the whole sample space. But what if I add that the president I'm thinking about has a first name of George? Does that improve your chance of guessing the right president? There have been 3 presidents with the first name of George, which means now our probability of guessing the right president would be 1 out of 3. Notice the denominator changed to the number of presidents whose first name is George and not the 45 in our entire sample space. By knowing additional information, we were able to update our probability. In mathematics, finding the probability of an event occurring when we know about previous events that have occurred is called conditional probability. And this is used in many places. Think about when you go to the doctor. We always fill out medical history to identify risk factors. This lets the medical professional decide if we're at normal risk or, based on our answers, are we at an increased risk for any conditions. Let's do a few calculations. The data in the table gives us information about shootings in Chicago in 2024 from January 1st to August 1st. The data has been separated by gender and if the victim was killed or wounded. We can take that data and add another column and row to give totals for each event. Let's find the probability that someone was killed. Here we take the total number of people killed, 361, and divide by the total number of elements in our sample space, 1,831. This gives us a probability of 19.72%. Now if we look at the probability someone is killed given they're a male, we want to look at the number of males that were killed, which is 318. Now we're going to divide by the total number of males, which is 1,561. This, as our probability, is 20.37%. Let's reverse that and find the probability someone is male given they were killed. Again, we look at the number of males that were killed, which is 318, but this time we divide by the total number of people that were killed, which is 361. This gives us 88.09%. Events A and B are independent if the probability of A given B is the probability of A, and the probability of B given A is the probability of B. When A and B are independent, the probability of B occurring does not affect the probability of A occurring. This also means the probability of A and B would be equal to the probability of A times the probability of B. Let's go back to our data. We found the probability of someone being killed was 19.72%. The probability someone was killed given they were a male was 20.37%. Because these two values are different, we can determine that killed and being a male are not independent events. Let's determine if the events being female and being wounded are independent. We'll start by finding the probability that the victim was a female. There were 270 females out of our total 1,831 victims, which is 14.75%. The probability someone was wounded is 1,470 over the total 1,831, which is 80.28%. The probability someone was female and wounded is 227 over 1,831, which is 12.4%. To determine if the events are independent, let's multiply the probability of being female times the probability of being wounded and see if it's equal to the probability of being female and wounded. We'll multiply 0.1475 times 0.8028 which is 0.1184. That's not equal to 0.124, which says the events female and wounded are not independent. Let's talk about what an independent event might look like. It might look like rolling a pair of dice. The probability of rolling a die and getting a 1 on the first die is completely unrelated to rolling the die and getting a 1 on the second die. To find the probability of getting 2 ones, I can multiply the probability of getting a 1 on the first die, which is 1 over 6, times the probability of getting a 1 on the second die, which is also 1 over 6, which says the probability of getting 2 ones is 1 over 36. When we know that events are independent, it helps us figure out the probability of both things happening at the same time. If we were given that the probability of A is 0.3 and the probability of B is 0.6, then the probability of A and B comes from multiplying the probabilities together. In this case, we would have 0.3 times 0.6, which is 0.18. Knowing when events are independent or not independent help us calculate probabilities. Make sure you read through problems and look for this keyword to help you in your calculations.